Today's video will discuss Chapter 8.1, Monomials and Factoring. So I'm going to start with a monomial, and what we are going to do is find the prime factorization of this monomial. And you may remember this as a factor tree. And so the idea is that this is the same as 20 times x to the third times y squared. And so I need to find the factors of 20. Now remember, it doesn't matter which two factors I choose, as long as I keep going until I get a prime number. And so maybe I choose like 2 and 10. 2 is prime, so I'm going to circle 2 because I know that's the end of my factor tree for that branch. And then this is 2 and 5, and 2 and 5 are also prime numbers. And so then I know that this will turn into 3 x's, x times x times x, and this is going to turn into 2 y's, y times y. So the prime factorization of 20 x to the third y squared would be 2 times 5 times x times x times x times y times y. So all I'm doing is breaking down these numbers and then writing, right, those are the x's, those are the y's, and here obviously is where the 20 is coming from. Alright, the second problem you're going to see is one that deals with greatest common factors. And so what we need to do is similar to what we just did. We need to find the prime factorization of 12a squared, b squared, and c, and then need to find the prime factorization of 18a, b to the third, and then remember GCF means greatest common factor, so I'm trying to figure out what is the greatest number that they have in common. And so as I break down the 12, this could be, let's say, 2 and 6, and then this would be 2 and 3. So the prime factorization here would be 2 times 3 times a times b times b times c. And then over here, let's say this is 2 and 9. I know 2 is a prime number. And then 3 and 3. And so this is going to be 2 times 3 times 3 times a times b times b times b. Now this is where sometimes people get confused, but what I'm looking for is what they have in common. So for example, they each have a 2. So I'm going to circle the 2 because they have that in common. They each have a 3. But you'll notice that this one has an extra 2. There's no more 2's over here. This one has another 3. There are no more 3's over here. So the only numbers that they actually have in common are 2 and 3. And then I know that here's an A and an A. This has a B and a B, and then there is another B and B in common. So you'll notice this one has a third B, but there is not a third B over here. And this one has a C, and there is not a C over here. So in common, they have 2 times 3 times A times B times B. Now when you write the greatest common factor, you actually want to write this out as a number and use exponents. So 2 times 3 is 6. And then this is A, B squared. So that would be the greatest common factor of these two numbers would be 6ab squared. All right, and then the final example is one when, and this is not necessarily more difficult, but if I want to find the greatest common factor of 3 numbers, all I need to do now is find each of these, right? And so this 8 becomes 2 and 4, and then 2 and 2. So this would be 2 times 2 times 2 times w times z. It's 12. I could break down to, let's say, 3 and 4, and then 2 and 2. So I'm going to write this in order now. So this is going to be 2 times 3 times w times z times z. And then over here, 4, and then the 4's can break down into 2, so I'm going to end up with 4 2's. So this one would be 2 times 2. I'm going to run out of room if I keep going that way. 2 times 2 times 2 times 2 times w times z. Okay, and notice, part of the reason why I put that line through my z is so that you won't mistake my 2's with z's, because they obviously look common. So these are 2's, and then those are my z's. And this one doesn't really look like a z either, huh? All right, so now what we're trying to do is find out what do they have in common. So they each have at least one 2, so I see that 2 is in common, right? They have a second 2 in common. So notice I can't circle unless they each have it. So like for example, this one and this one have another 2. This does not, so they do not have that in common. Neither of these two have a 3 in them, so they don't have that in common. So I'm now on to the W. They each have a W. And then you'll notice that there's another W, but these two do not have a W, so I'm not going to circle that. And then they have this one Z in common. And even though there's another Z here, there aren't any more. And so in common they have, I'm just going off of what is circled, 2 times 2 times W times Z. Now I want you to notice, this is a common mistake, is that people will write 2 times 2 times W times Z times 2 times 2 times W times Z times 2 times 2 times W times Z. You can't write it on each one. So by circling it, what I can do is then just take one of them, and that's my greatest common factor, anything that's circled. And then from here I need to simplify this, and this becomes 4WZ. So the greatest common factor between all 3 of these numbers, or monomials, is 4WZ. Right, it's the same idea. I'm going to come back to that sec, but it's the same idea here, right? This is 2 times 3 times A times B times B. I don't write it a second time, otherwise you're just doubling everything, right? It doesn't matter which of these two you look at. I mean, I typically look at the one that's on the left, but these I just brought down. Right, so that's where the 2 times 3 times A times B is coming from, and then same thing here. Doesn't matter which of these 3 factor trees you look at, either way I'm just kind of bringing down what I have circled, and then I obviously have to kind of multiply it out. So this is going to be in long form, I got to turn it back into short form. Alright, that's all we got for you on factoring. Thank you very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.